Water, the staple of all life on Earth. Every day, 2 million tons of sewage is expelled into our waters. That's equivalent to the weight of the human population at 7 billion people. Water pollution is as dangerous to animals as it is to us. The consequences of pollution can be seen in the Ganges River in India. People using this river as a water source are at high risk of attaining waterborne diseases. Due to the pollution of toxic waste, Ganja has the highest cancer rates in all of India. In fact, the highest gallbladder cancer rates for women was reported in this area. Here in the United States, factories are required to pre-treat the wastewater they release out to sewers. Alex Church, an environmental health and safety technician, is an expert in water treatment. Companies that use water in their manufacturing process employ experts like Alex to remove the toxins in their wastewater.
The wastewater system in this factory isn't a purification system, it's just a pre-treatment system to make the water good enough to transfer in the public sewer system so it won't leach out and contaminate the soil. Our county restricts 3 heavy metals that we use in our factory, which are cadmium, lead, and zinc.
Chemicals such as lead and cadmium are considered as carcinogens. Carcinogens are cancer-causing substances. The removal of these chemicals is vital to the overall health of every living organism. So how does this process begin? It all starts in Tank A, where the wastewater is collected.
So this wastewater system is a precipitation system, and it starts down here in Tank A. This is where all the water collects from all different parts of the plant. So all the dirty water is kept down there, and it's mixed by the stirrer here to keep things flowing.
During this process, 3 chemicals are used to remove contaminants from the water. Ferrous sulfate is used to lower the pH of the water. Then, sodium hydroxide is used to raise the pH. And finally, a flocking agent is used to remove any other contaminants.
So we're going to add some ferrous sulfate. Under this hatch, we have a little compartment and an auger that feeds it into a downpipe, and it goes into Tank B. The vacuum is air collection. It gets a little dusty, and then your hair starts to smell like rusty nails. And we have pumps that pump it here into Tank B, and we add ferrous sulfate to bring the pH down. And behind it we've got Tank C, where we're going to add sodium hydroxide. We're going to make the pH go up to about 9.2. And once it's settled there, it starts to flocculate, and the metals start to come together.
Flocculation is the act of joining contaminants together, causing them to coagulate and sink to the bottom of the container. Once Tank B reaches a pH of 6, the water is pumped to Tank C, where sodium hydroxide is added to raise the pH to 9.2.
Let's go look at Tank C. This is where the sodium hydroxide is added to bring the pH up. Here you'll start to see some of the metals start to come together. You can see it's a very dark color because of the chemical reaction.
The water then moves to the clarifier, where the flocculant causes contaminants to become denser than the water and sink. This settling material is called sludge. The clarifier is a tank with a conical bottom and an inverted cone on the inside. When the sludge starts to settle, it goes to the bottom of the tank and is pumped out to a filter press.
So this is the clarifier. The water's going to come through this tank here. This is where the sludge is going to start to settle and displace all the clean water up through that inverted cone. It'll go through this tube and down to the surge tank.
The surge tank is a small tank where the clean water is collected, so it can be pumped through a 5-micron filter, further purifying the water. Ever wondered how small 1 micron is? Consider this. 1 micron is 100 times smaller than the width of a human hair. Once the water has passed through the clarifier, it then moves to a sample station, where it is tested before being sent out to the sewer.
So we're just going to take a little sample of the water and see what it looks like. Color is always a good indicator. Now this isn't bad. We'd like to see it clearer, but this would definitely pass our test.
There you have it. The water has been purified of heavy metals and is now on its way to the State Processing Center for further purification. But let's not forget about the sludge. Where does it all go?
So this is our filter press. It takes all the sludge from the clarifier and filters it through 4 different filters.
Once the sludge has completed a drying process, it is shipped out to companies who harvest and recycle heavy metals. With increased regulations, enforcement, and global cooperation, pollution can be reduced.
It's important to control and reduce pollution because contaminants that we use in our factory can negatively impact soil and aquatic life and our crops and plants.
As the biggest source of rapid pollution on Earth, it is our responsibility to purify the water of man-made toxins. We must remove pollutants from our wastewater so that areas like the Ganges River can one day be pollution-free.